Hello everyone, I hope all of you are doing good. So today we are going to discuss about two important terms. That is what is distance and what is displacement. I usually saw in the classes, normally students got confused in displacement. That okay, we know what is distance, but what is displacement? So I will personally give my best efforts to explain you what is displacement. First of all, let's have a look at what is distance. So distance traveled by a body is the length of the path taken irrespective of the direction of motion. What it means here in simple words, actual path length. Actual path length. That is what? That is distance covered by your body. So in this case, as you can see, these 2 points, this is the point A and this is the point B. So right now path you can see, it can be like this also. Sorry for that. So skip this. This distance can also be like that. Okay, that is what actual path length, or it can be like that also. So that is what? That is distance. If these are the 2 points, this is the point A, this is the point B, the actual path length, that is what? Distance. So I hope it is clear to you. Now talking about its unit, the SI of distance traveled is meter. How it is meter? Have a look. What is this? Here, this AB, that is a length. So yes, the SI unit is meter. Talking about CGS, that is centimeter. I hope you all study about the different system of units, MKS, CGS and FPS. So in CGS, unit is centimeter. Now talking about displacement. What is displacement? So let's read the statement first. Displacement of a body is the shortest distance traveled in a direction from initial to final point. That is what? Displacement. Remember one more thing. It is always a straight line path. Straight line path. What is displacement? It is a shortcut, you can say. Shortest path from initial to final point. So in this picture, you can see this is a point A and this is a point B. So this is also a distance, no doubt, actual path length. Or have a look here. This distance, suppose a body goes from point A to B, it can go like this in a straight path. Yes, it can also go like this. This person can also go like this. Like this. So that is what? This is actual path length. This is distance covered by your body. But this displacement, that is what? Shortcut from this point A to B, the straight line path. That is what? Displacement. One more example. What is displacement? Look carefully. This is the point A and this is the point B. Suppose they are very close right now. So a person started from here and goes like this and reaches to the point V. So what is the displacement here? This is the displacement. Let me highlight this with the another color pen, with the blue one. This is what? Displacement. Displacement. The shortest path from initial to final point. I hope now it is clear, and it is always a straight line path. This AB, that is what? Distance. So I hope now it is clear to all of you what is distance and displacement. And in this picture, as you can see, just a second, here, this is your home. Suppose this is your school. This is your home and this is your school. So this is what? The actual path length, the distance covered by you. And the shortest path from initial to final point. I know By road, you people are going through the bus. So distance is, you are doing what? You are covering the distance. This is what actual path length. Suppose this whole length is what? Around 10 kilometer. But there is also a shortcut, a shortest path. So in that path, only you can say very rough vehicles like 4x4 cars, especially the Fortuner, vehicle like this, because that road, that is not, you can say good. It is a very difficult terrain. So you can also go from that way. So this distance is lesser, and this is what? Displacement. The shortest path from initial to final point. Here home, this is the point A, you can consider, and this is the point B. I hope now it is clear to you what is distance and displacement. One more thing, this displacement is a vector quantity because there is direction associated with it. What is displacement? Distance traveled, distance traveled in a given direction. So let's look at the few questions, then we will proceed. Suresh walks from point A to B. This is the point A, this is the point B, and then again from B to C. So he goes from A to B and then B to C. Calculate distance and displacement. So what is the initial point of the Suresh? This is the initial point, and A to B and then from B to C. So C is what? C is the initial point of the Suresh. So what is the distance? You can say this distance would be this AB, this length AB plus BC. And talking about the displacement, it is always a straight line path. So this is what? Displacement. This AC. AC is what? Displacement. So I hope now it is clear to all of you. So today in this video, we are going to learn about some important terms used to define motion. Like speed. What is speed? What is velocity? What do we mean by that? What information we are getting from these terms? So let's start. So as you can see the definition, the distance covered by a body in unit time is called speed. Distance covered by a body in unit time. Speed is what? The formula, I hope you already studied it. Distance upon time. Distance upon time. Is it? The distance covered by a body in unit time is called speed. But my question is that usually I saw in the classes, when I ask this question, what is speed and what information you are getting from speed and velocity, people are like, okay, distance covered by your body in unit time. But my main motive is what information you are getting from these two terms, speed and velocity. So let's have a look. What it tells us. Speed, it tells us how, what speed tells us? How fast or slow a body is moving. Body is moving. Or you can say, or at which rate one should move in order to reach his/her destination. At which rate one should move in order to reach his/her destination. That is what speed tells us, or you can say at which rate a body is moving, destination, TION. Okay, so that is what speed tells us. For example, this is a point A and this is the point B, and the distance between from A to B is suppose 100 kilometer. Fine. and this is an object. Suppose this is a person. Suppose this is a person, okay, and he covered this distance A and B and took around 2 hours. 2 hours in order to complete this distance from A to B. There is one more person who also covered the same distance, that is this AB, the same distance, 100 kilometer, and he took around 5 hours. 5 hours to cover the same distance. So speed, you already know what is distance covered by a body in unit time, distance upon time. So here 100 divided by 2, how much? 50 kilometer per hour. Is it? And here 5 to the 10, so 20 kilometer per hour. So right now we can distinguish that which one is moving faster. Look at the statement here. How fast or slow a body is moving, or at which rate one is moving, or at which rate one should move in order to reach his her destination. Suppose right now you all are watching my video. So your distance from the school and the home is suppose 10 kilometer, and you started walking to the school in 8 a.m. in the morning, and your time, your school time is how much? 9 a.m. So if you started early, obviously you will go little bit slowly to the school, है ना? But if you suppose you started going to school from your home, you started a little bit later, you can say 8:40, then you have to do what? You have to move fast. Means you have to increase your speed in order to reach the school at the time, at the proper time. That is 9 a.m. So that is what speed tells us. At which rate one should move in order to reach his her destination. Fine. So distance upon time. Yes, distance upon time. So unit is, what is the SI of distance? Yes, meter, and time second. So the unit of the speed is meter per second. Okay, the unit is meter per second, or we can write it like this also, meter per second. So I hope now there would be no confusion in speed, that what speed tells us. Now talking about velocity. What velocity tells us? Here the SI unit of speed is meter per second. Talking about the CGS, that is centimeter per second. I hope you already studied about the different system of units, MKS, CGS, FPS. So in CGS we measure the length in centimeter. So centimeter per second. Okay, it is already written over here, centimeter per second. Now one more thing, maybe you should know this thing, that is what? Conversion from kilometer per hour to meter per second. So let's have a look. There is a relation over here. Conversion from, I'm writing here, kilometer per hour to meter per second. Okay. So right now this is a formula. This is a conversion from meter per second to kilometer per hour. So let me tell you how this formula is coming. 18 by 5, or from kilometer per hour to meter per second, 5 by 18. So let's have a look. Can I write it like this? Kilometer per hour equal to meter per second. Can I write it like this? Obviously yes. Now in 1 kilometer, how many meter? You all know. How much? 1000. Is it? 1000. So I'm writing in the brackets. And talking about 1 hour. So in 1 hour, how many minutes? 60 minutes. And right now, as you can see, the unit is in the seconds. So in 1 minute, how many seconds? 60 seconds. So again from hour to seconds, 60 into 60, 6 is 36. So upon 3600. Is it? So sort it simply. 2 zeros, 2 0 cancel. And yes, 2 5 ja 10. And 2 1 ja 2, 2 8 ja 16. So we are getting here 5 by 18. So can I write it like this? Kilometer per hour equal to 5 by 18. Yes, I can write. So that is what it is written over here. If you have to do what? If you have to do conversion. Okay, just a second. Eraser. I hope you all noted down. if you have to do conversion from kilometer per hour to meter per second, you have to simply do what? Let's have an example. I have to convert 72 kilometer per hour to meter per second. So simply I have to multiply by 5 by 18. 72 into 5 by 18, and you will get the magnitude in meter per second. So let's solve it. So 2 9s are 18, 2 1s are 2 3s are 6, and 2 6s are 12. So 3 3s are 9, and here 3 1s are 3, 3 2s are 6. So talking about 12 5s are 60, 60 upon 3, 3 2s are 6. So we got here to 20 kilometer per hour to meter per second. 20 meter per second. That is the conversion from kilometer per hour to meter per second. Same way, if suppose we have to do what? We have to do the conversion from meter per second to kilometer per hour. Kilometer per hour. How we can do? Just opposite. Right now we are doing what? Kilometer per hour to meter per second. That is what we have to simply multiply by 5 by 18. So meter per second to kilometer per hour, just opposite. You have to multiply the any magnitude with the 18 upon 5, just opposite. As simple as that. Remember. For example, again this 20 meter per second. Let me solve it for you here. So 20 into, as I told you, 18 by 5. If you have to do conversion from meter per second to kilometer per hour, 18 by 5. So yes, 5 4s are 20 and 18 4s are 72. So 72 kilometer per hour is the conversion from meter per second to kilometer per hour. So similarly, you can do the conversion also. I hope you got it. Now moving ahead to the velocity. Okay, so it is written over here, rate of change of displacement, or you can say rate of change of position of a body in a specific or given direction. That is what velocity. But I want to put a question here. We are also doing our work with the speed. Then what is the need of velocity? Why we need velocity? Because to know the why we need velocity, to know the exact position of the object. To know the exact position of object. Where is the object? Like where that object is moving, towards north direction, south direction, east, west, where it is moving, towards my right, towards my left. So speed plus direction, that is what velocity. I'm writing here, speed plus direction. Direction, that is what velocity. You can say simply, it is just one step ahead from speed. It also tells us the direction, that where that body is moving, in which direction it is moving. That velocity tells us. So rate of change of displacement. Okay, and we can also write like this. What is displacement? Distance traveled in a given direction. Distance traveled in a given direction. Given direction upon time as it is. So one more thing, you all know displacement is a vector quantity. Speed is a scalar quantity, and velocity is a vector quantity. I'm writing here, vector quantity. Okay, so again talking about the unit of displacement, as a unit of displacement, that is meter, and the time, that is second. So the unit is what? Meter per second. So one more information, The SI unit of speed and velocity, that is same, meter per second, or in CGS, centimeter per second. So I hope now you understood about the difference between speed and velocity, how these two terms are differentiated from each other. Speed, it tells us what? At which rate body is moving, or you can say how fast or slow a body is moving. But velocity tells us to know the exact position of the object, that where that body is going, towards north direction, south, east, west, where that body is. Okay, today in this video what we are going to learn about acceleration. What is acceleration? So I hope till now you understood about what is speed and what is velocity. Now talking about acceleration. So first of all, let's have a look at the definition. Rate of change of the velocity of an object with respect to time. That is what? Acceleration. Or you can say change in velocity per second. That is what? Acceleration. Now in simple words, let me tell you. Suppose this is the point A, this is the point B, this is the point C. Fine. So suppose there is any body, any object who is moving towards this point C, and the velocity of that object, velocity you all know, what is velocity? Speed plus direction. We are also mentioning here the direction. So a body started from the rest and moving with the velocity, that is suppose 4 meter per second. That is the velocity of the object. And what information we are getting here? A body starts from rest. I'm writing here. Starts from rest and achieves a velocity 4 meter per second. At this point B, the velocity was 4 meter per second. Now you have to tell me what? We just studied the definition. Change in velocity. So how we can find the change in velocity? Look, what is this say? A body starts from rest. So U is what? Initial velocity. I'm writing the important terms here. You can also note down. Initial velocity. V, that is final velocity. Final velocity. So can you notice the change in velocity here? Here the body started from the rest. So initial velocity is what? 0. And at this point B, and he took around, you can say 2 seconds to go from A to B. Fine. So change in velocity, del V, we use this symbol in order to tell the change. And for the small interval, d, ds by dt, you will learn in higher classes as well. So this del is for change. So what is the change here? This final minus initial velocity. I'm writing here Vf, that is the final velocity minus initial velocity. So what is the change here? 4 minus 0, how much? 4 meter per second. That is the change in velocity. Now what is acceleration? Change in velocity. Rate of change of velocity. Rate means what? We are talking here with respect to time. So how much time he took goes from A to B? 2 seconds. So 4 upon 2, how much? 2 meter per second square. Now have a look here. 4 meter per second, and the time is second. Change in velocity. First of all, let's understand the unit. Change in velocity. And you all know what is the unit of velocity? Meter per second. And the time, that is what? Meter per second. So the unit of velocity is, it merges up here. That is meter per second square. Or we can also write it like this. Meter per second square. I hope you know this. I can also write it like this. You all know now? Multiplication in the mathematics. So yes, meter per second square. That is the unit of acceleration. Now moving ahead, yes. So A to B, the velocity was till this point B, that is 2 meter per second square. Now that body is again moving from this point B to C, and the velocity of that person is 8 meter per second here. 8 meter per second. When he moved from B to C, and the time he took, that is around 4 seconds. So can we find out the acceleration here? Yes, we can find out. Again, what is change in velocity? First of all, notice that is 8 minus 4. How much? 4 meter per second. And the time he took, that was the 4 seconds. So how much? 1 meter per second square. So as you can see here, what we just find out, that is what acceleration. Change in velocity. Change in velocity. Rate of change of velocity. Rate means what? We are talking here with respect to time. So yes, when he moved from A to B, the acceleration was 2 meter per second square. So as you can see, he just speeded up. In layman language, we are used to say that. And B to C, he was applying the brakes. Suppose. So here, acceleration was 2 meter per second square, change in velocity, and from B to C, 1 meter per second square. So this is what? Positive acceleration. Acceleration that is also of two types. Here, it is accelerating, body is accelerating. Like in the cars, we just press the accelerator, but accelerator pedal, the car just moves forward. What we are doing? We are just changing the velocity. So yes, that is positive acceleration. And when the driver that is applying the brakes, that is what? Retardation. Negative acceleration. Deceleration. That is the same thing. Okay. So I hope you right now, you know about the acceleration and how we can find out this acceleration. Acceleration is a vector quantity. So final velocity, that is v minus u upon t. So you can find out the acceleration. So I hope